Hello again, Mr. Hein is here. This one's 213, which is much like 212. It's just another day of it. So it's left and right endpoint summations. So we'll just generalize these, go through it kind of quickly, and hopefully catch on to the pattern. So let's say you had a function g of x, and you wanted to find the area under the curve on 0 to 5. And for part A here, we'll say that it uses, you want to use 10 rectangles. So then your summation is going to be the width of each rectangle, which is 5 minus 0 over 10, which is 1/2. The width of every rectangle times the height of every rectangle, which will be the function, you see the function being f, which is the function g. And if it's left endpoint, you always start at the left point of your interval. So it'd be g of 0 plus, so this right here again is your linear pattern, plus, and then how is it changing? Well, it'd be changing by widths of 1/2, so it'd be 1/2 k, where I'm going to use k as my index here from 0 to 9 for the 10 rectangles. And there's your answer for that one. So 0 would be the first rectangle, k equals 1 would be the second rectangle, k equals 2 would be the third rectangle. If you wanted right endpoint, then the only difference in the area is that it would go from 1 to 10. So k equals 0, that very first rectangle that you draw, you would disregard and you'd start at the next rectangle over. And then everything else stays the same. So it'd be 0 plus 1/2 k. And there's right endpoint. Looked at a second example, and then I'll probably call this video done, so it's a shorter video today. Say you wanted 50 rectangles. Then the left endpoint, it'd be your area is equal to, and we'll use b from 0 to 49 for the 50 rectangles. Your width of each one, which would be 5/50ths or 1/10. Because 5 over 50 equals 1/10, where 5 over 50 comes from the length of your interval that you're looking at divided by how many rectangles you want. So that's the width of every rectangle, and then the height of every rectangle is going to follow the pattern of the first value on your subinterval 0 plus, and then every rectangle that moves over is moving over by a width, which is 1/10. And then we'll use b as the variable to match the index. And there you go. And right endpoint would be, I don't want to use b again. We'll use h. Like I is pretty common. 1 to 50, and then that will work for that. And there you go. So hopefully you caught on. If you want to know more about where these come from, watch the previous video where I worked through an example a little bit slower and show you where that pattern comes to be. Or even the video 2 days before on 211 on trapezoidal. For trapezoidal, you'll see a more advanced use of summations. All right.